Two of the biggest challenges of Tesla currently are its battery and its manufacturing equipment production for Model 3. In fact, if these two problems were solved, we would be seeing the Fremont factory producing at its full capacity right now, which would mean 5,000 cars per week instead of 10. So today, I want to talk about Tesla battery to see what's really going on inside our beloved Tesla, the vehicle of the future. First of all, let's start with the basics. Most batteries consist of three parts: anode, cathode, as well as the electrolyte. They store and release energy by moving electrons from one end of the battery to another, typically from the negatively charged anode to the positively charged cathode when we are powering a device. This is how your Tesla is powered. The process is analogous to lifting things upward. You can think of charging as the process of lifting electrons upward. When charging is completed, electrons in the battery gain a lot of potential energy and have the natural tendency to go down. So that's what happens when you drive your Tesla. Electrons release the stored potential energy and power the motors in Tesla. The motors turn the wheels and the car moves. The process is really simple, but it's easier said than done. There are two types of lithium-ion batteries right now for Teslas, the 1865 batteries and the 2170 batteries. Their names stem from their differences in the dimensions. The 1865 batteries are 18 millimeters in diameter and 65 millimeters in length. Same goes to the 2170 batteries. So if anyone tells you the 2170 batteries are simply better than the 1865 batteries, they couldn't be more wrong. However, that said, the reason why Tesla's new cars use the 2170 batteries is because of the different form factor. The 2170 batteries have greater energy capacity and makes better sense considering multiple variables including cost, power capacity, energy capacity, lifespan, and so on. This means perhaps faster charge rates, greater range, and longer lifespan of the car. Furthermore, people think that batteries used in EVs are just like the ones in our smartphones. It is not true. Remember the cathode, anode, and electrolyte I talked about just now? Here is why it matters. In all lithium-ion batteries, the anodes are made of graphite and electrolyte is made of lithium ions. However, the material used in cathode varies widely. Here is an infographic that explains everything. Like all my videos, I don't want to go into the science of it, but I think it's worth emphasizing that Tesla's battery technology is one of its biggest advantages in the EV market. The most recent launch event, which unveiled the Roadster and the Tesla Semi, Tesla shocked all of us with its extraordinary products that obviously are enabled by some kind of battery breakthroughs/improvements. Elon did not talk about it, but calculations are predicting charge rates in the league of megawatts, which is a 10-fold improvement from the current superchargers. Moreover, it's not just about the batteries, it's also about the production of the batteries. Technology is one thing, realizing the technology is another. The Gigafactory in Nevada is doing exactly that. Obviously, viewers of this channel know about the production problems Tesla has been facing in the past few months. But that shouldn't cloud our minds for the big picture. The last official words we've seen from Tesla on battery price was in April 2016, when Tesla's VP of Investor Relations confirmed the battery price of $190 per kilowatt hour. So considering the economies of scales, vertical integration, and improved raw material utilization, the Gigafactory should be able to bring down the cost of a Tesla by thousands of dollars, which is why Tesla will do better in the future. Here we're talking about less than $100 per kilowatt hour by the end of the decade. Furthermore, since this video is titled Tesla Battery 101, I probably should not just focus on batteries of Tesla cars. A big portion of those batteries are also made into Powerwalls and power packs, which has been proven to be a big success in many occasions. Just this year, Tesla has built energy storage facilities in Australia, Puerto Rico, California, and so on. All of them aim to solve local energy problems. It is worth mentioning that the Powerwalls use different batteries than the cars. The Powerwalls use NMC batteries instead of NCA batteries. This is due to the difference in their characteristics. For example, NCA batteries are better for fast charging, and NMC batteries are more cost-effective. Furthermore, many of us know that Tesla's 1865 batteries and the 2170 batteries are cylindrical, but what we often take for granted is that cylindrical lithium-ion batteries aren't the only design in the world. For example, the Nissan Leaf has pouch-shaped batteries instead of cylindrical ones. Same goes for Chevy Volt. Hence, Tesla's leadership in the EV market is not a coincidence. It stems from Tesla's strong R&D. The core technology of Tesla, however, could not be easily copied by other manufacturers. Though the exact numbers are not available, the official plan is for the Gigafactory to reach a battery pack production capacity of 50 GWh. Once at full capacity, the Gigafactory is expected to produce up to 150 GWh of battery packs a year, enough to produce 1.5 million electric cars. Lastly, the future of EV batteries have many possibilities. Although there is no indication that Tesla is going to change its lithium-ion batteries, those possibilities do mean a bright future for electric cars and a sustainable future. In recent years, the most hyped alternatives for lithium-ion batteries are solid-state batteries, as well as lithium-air batteries. Furthermore, there are also discussions about sodium-ion batteries, which will be much cheaper than the lithium-ion batteries because of its relative abundance. It's worth pointing out that these alternatives are not happening in the near future, but in 10-20 years' time, these technologies are definitely a possibility.
Well said.
Alright, thanks for watching. Sorry for not uploading last week. I was traveling in China and you guys know about the Great Firewall. However, the trip did renew my passion for talking about innovations in China. I'm sure you guys will be surprised how the Chinese are changing the game for mobile payment. Nevertheless, hope you guys enjoy this video. I'll catch you guys in the next one. Again, I'm Lei. Peace.